Hello everyone. So, we will continue with the measurement techniques of tactile responses of fabrics. So, we are continuing with subjective assessment techniques. After the technique proposed by Matsuo, who adapted Weber's and Fechner's law of psychophysics. Next is that technique is by Kawabata, who has developed the subjective assessment technique. The assessment of fabric handle characteristics was based on tactile sensations caused by fabric mechanical and surface characteristics. Okay. And the final judgment of the fabric, the handle judgment, is based on the suitability of mechanical and surface property for a particular application. Okay. Because that particular application that may be may not be actually suitable for other end use, okay, for a particular fabric. Suppose for a particular application we may need a stiff fabric, okay, that, but or for other application we may need altogether different aspects. So, the final judgment is based on the particular application. So, all this subjective judgment, they have got their own limitations. So, this although this gives directly it is correlated with the tactile comfort of clothing, like a sense of touch, okay, but they have their limitation. Okay. So, this sensations of roughness, sensation of smoothness, softness, harshness, flexibility, thickness, scratchiness, okay, against the skin, that we can directly sense. But main problem is that it is a lack of repeatability and chances of error, actually, and it depends on person to person. Okay. So, even a particular fabric, it is for a person, I may perceive a particular fabric differently at different actually mental condition, psychological condition. So, that actually creates problem. This subjectivity, it depends, it changes with the environment, although it's actual sensation, but getting a standard value, it's difficult. If my physiological condition changes, I will perceive a fabric differently. This is actual subjective responses, but the repeatability is not there. We cannot give a particular value, we cannot reproduce the value particular fabric. So, to reproduce or to get a standard value irrespective of the judgment, irrespective of the perception, we need a measurement technique which is objective in nature. So, now we will discuss the different objective measurement technique for fabric tactile responses or fabric handle related characteristics. It is actually proposed long back by Pierce in 1930s, and Pierce identified the fabric tactile responses, various tactile characteristics of fabric which directly sends tactile responses. These are bending, compression, specific volume and surface property. So, Pierce in 1930s, long back, he proposed that if we measure bending stiffness, if we measure compressional characteristics or specific volume of fabric or surface characteristics, that will, these things will give our tactile responses. Then in 1958, Haworth and Oliver identified 3 attributes for suiting fabric. These are surface smoothness, fabric stiffness and thickness. These are all measurable. So, objectively if we can measure these characteristics, we will get the tactile response. Actually we can guess the tactile responses of fabrics. Next, in 1980s, So, Japanese team, they have come up with different attributes for, one is for summer clothing and other set is for winter clothing. They have actually devised different objective aspects like fullness, if we can measure the fullness or springiness, stiffness, crispness and hardness. So, these 4 characteristics are directly related with the summer clothing, and the winter clothing they have come up with these aspects of smoothness, fullness and springiness. These 3 aspects are related with the winter clothing, like springiness and stiffness. These are common for both summer and winter. Fullness is common for summer and winter, but smoothness in winter, what they have proposed, that in winter clothing we actually need smoothness characteristics. We have to measure smoothness characteristics for at least for winter clothing. Similarly, for summer clothing, the crispness or hardness they are important. Okay. They measure the crispness or hardness. Then Winokur et al. In 1980s, after that, so after Japanese they have proposed, they have come up with a wide range of characteristics, wide range of feel. Okay. So, and they have correlated with the fabric characteristic like bending. If we measure the bending rigidity, it will give idea about the stiffness of fabric, whether the fabric is stiff or limp. We can get idea about by measuring the bending rigidity of the fabric. Similarly, if we can measure the frictional coefficient, what they have proposed, we can measure the roughness characteristics. If we measure the thickness and compressional deformation, so then we can measure the fabric handle related characteristics. So, they have proposed 9 actual pairs of polar adjectives, and they have actually they found that these are related with some of the fabric objective mechanical characteristic. So, these 9 pairs of polar adjectives are whether the fabric is limp or crisp, is it flexible or stiff. So, these are the subjective responses. We can tell, okay, you tell the whether the fabric is limp or crisp, is it flexible or stiff, is it firm or sludgy, is it scratchy or silky. So, these are the terms. So, polar adjective. So, that the person who is perceiving the sensation, this type of tactile sensation we can actually get. Fine or coarse, is it the fabric is fine or coarse, smooth or rough, soft or hard, light or heavy, thin or thick. So, these are the actually expert, they sense this tactile sensory attributes, okay, and they are related with the low stress mechanical characteristics. And this group they have actually proposed that these are we can correlate with the low stress mechanical characteristics of the fabric. There are various mechanical characteristics, and they could actually find that these all 9 adjectives are, these are all these tactile attributes are related with the mechanical characteristics. Let us see how are they related with the mechanical characteristics. Now, try to see limp or crisp, film or sludgy, flexible or stiff. These attributes, tactile attributes are directly related with the bending rigidity. if we can measure the bending of fabric, that they have fabric characteristics, that we can, if we can measure the fabric bending characteristics, we can get idea about these polar attributes. Scratchy or silky, smooth, rough, fine, coarse, they are related with the fabric frictional characteristics. So, if we by measuring the frictional characteristics, we can get all these characteristics idea. But frictional characteristics will not only help in this aspect. What type of friction? Is there any stick slip? Is there any what is the frictional curb characteristic, curb, what is nature of curb? Mu will give some idea, but whether the fabric is fine or coarse, this type of characteristics we can get by detailed analysis. Thick and thin definitely by thickness, fabric heavy or light definitely by measuring the mass per unit area, and soft and hard it is by compressional characteristics. So, if we measure the bending, friction, thickness, mass per unit area and compression, these are the mechanical characteristics. By physical measurement we can get the value, and we can actually we can propose, we can get idea about this tactile responses. Next measurement is that objective measurement is the Kawabata instrument, which is most popular, very popular instrument of objectively measuring the fabric handle characteristics. So, Kawabata system, it measures the tensile characteristics, low stress mechanical characteristics. It is not the up to the end point, up to the breaking point, it is at low stress mechanical characteristics. The tensile characteristics it measures the shear behavior, bending rigidity, bending characteristics, compressional characteristics and surface related properties. So, they have, it has got 4 different test modules, we will discuss one by one in detail. In module 1, it measures the tensile and shear related characteristics, then it is a bending, compression, and fourth one it measures the surface related characteristics. So, Kawabata again, like earlier, Kawabata also gives idea about the fabric handle related characteristics or fabric tactile characteristics correlated with the fabric mechanical, low stress mechanical characteristics. Okay. So, what he has proposed, he has proposed 6 different terms like Cauchy, Hari, Fukuyama, Kishimi, Shinayakawa and Shari. This 6 characteristics, this Japanese term, they are related with the fabric low stress mechanical characteristics directly. So, let us discuss in detail. Like Cauchy, it is the hand expression is Cauchy, it is related with the stiffness, it is directly not stiffness, it is not the exact stiffness, it is some feeling of stiffness. We may by Cauchy we cannot directly say it is a stiff or okay, higher stiffness will give you higher Cauchy value, but it is not, we cannot say it is directly it is stiffness, it is a feeling of stiffness. Now, we can, it is a tactile feeling of stiffness, it is a Cauchy. Similarly, Hari, it is a anti-drape stiffness, again it is a stiffness, but Cauchy and Hari they are different, it is a anti-drape stiffness. We have to actually get the expression. So, and see there is a difference between Cauchy and Hari. but this difference we cannot express, we have to actually feel, and by that feel we can get from different characteristics and we can measure the hurry. That, and we will discuss one by one, we will discuss different research study, then we will get clear idea. And these Handel related expressions are directly gives us as the tactile responses. Fukurami, it is a fullness and softness, it is not the softness alone, it is a fullness, some fullness characteristics. Okay. Kissimmee, it is a scroopy, silk like feeling, it is not smooth, it is not pure smooth, it is a silk like scroopy feeling, some harshness, something, some softness, some smoothness, this type of feeling, it is Kissimmee. Sinai Akasha, it is a soft, flexible and smooth feeling. Like this Fukurami softness and Sinai Akasha softness, they are different. Its softness along with the flexibility, along with the smoothness. If we get some combined feeling, it gives the Sinai Akasha. Then crispness, this is the crispness, it is not the softness, it is not the smoothness, some crispy feeling, like some particular fabric, if we touch, it gives some crispy feeling. So, that is it is a shari. Now, let us see, now to get this value, what are the Handel or low stress mechanical characteristics related with this Cauchy value or this type of values, like Cauchy. What we have seen, it is a stiffness, it is a stiffness, it is primarily related to the bending stiffness, it is not the only, it is a primarily it is bending related. Now, if we try to get idea about the Cauchy, not the stiffness, it is a fabric with a compact oven structure made from springy and elastic yarn result a high Cauchy value. That is type of stiffness we are talking about. If we develop a fabric with a stiff yarn, like we are developing a fabric with a stiff rod with the open structure, it gives stiffness. It is like this is a stiff material, this will not give high Cauchy value, this is not the Cauchy value we are talking about. The Cauchy is different. Suppose, let us see a fabric we are producing from same warp and weft and same yarn we are using. Now, imagine that we are increasing the ends per inch and peaks per inch gradually, keeping the fabric same, keeping the yarn same, keeping it, suppose it is a woven fabric, a fabric with lower ends per inch and peaks per inch, gradually you are increasing and it has become compact, high ends per inch and peaks per inch, same almost same thickness, same yarns we are using, and it is stiffness will gradually increase as we increase the ends per inch and peaks per inch, and that we can say its Cauchy value is increasing. The type of stiffness it is increasing due to the increase in weave structure, compactness of the weave structure, and with that compactness now we are introducing one springy and elastic yarn, like we are using coarse spun elastane yarn, elastane coarse spun yarn we are using and we are giving a compact structure like denim. With a compact denim with elastane yarn, stretchable denim, that type of stiffness is Cauchy value. It is not the stiff fabric, it is that type of higher stiffness value, it is a Cauchy value. Okay. If we suppose a cloth, we are giving a starch treatment, a cotton fabric giving a starch treatment, it gives it becomes stiff. That does not mean we are increasing the Cauchy value. Cauchy means Cauchy softness will be there, but its a feeling is like that. Okay. It is a like hurry, it is anti-drape stiffness. It is a basically it cannot conform to our body, it is opposite to limb conformability, like a fabric which is actually taking the shape, that type. It's not like cushion cover or maybe a sofa cover, it is conforming to the shape of the particular furniture or anything, any cover. If it easily conform to that shape, that is basically it is a that type of it is called it is a less hurry value. And if it does not conform to that shape, we can say its hurry value is high. That means it is not directly related to the only the bending rigidity, it is related with the many other characteristics. And Kawabata and his group, they have proposed that these are related with the combination of all the more than one low stress mechanical characteristics with their different level of importance. Fukurami, it is a fullness and softness, does not mean that it is a fabric which is soft will give higher Fukurami value. It is a feeling, it is a tactile sensation, a sensation coming from a combination of bulk, rich and well formed impressions. That means, it has to be a bulk and rich value and well formed impression, and springy property in compression and thickness, accompanied by warm feeling, that actually reflects this quality. It is not only the compression, it has to be springy in nature, that means resilience should be there, the warm feeling should be there. Okay. So, that type of feeling is actually it is a Fukurami, it is a fullness, it is a richness, okay, well formed impression. Okay. That means, it has to come back, springiness. So, that gives the Fukurami value. So, that means, if we measure the compression, it is the not the only idea. So, it may be related with the bending, it may be related with other things. Next one is the Kishimi. Kishimi is it is a scroopy or silk like feel. So, it is related with the fabric thickness, weight, tensile shear. So, both tensile characteristics, shear characteristics and surface property. So, this will give us the value. So, if we keep everything constant, so our tensile characteristics like tensile elongation or shear characteristics change, then this Kishimi value will change. That means, Kishimi value, if we it is a function of the fabric thickness, weight, tensile, shear and surface characteristics, but their importance, relative importance may be different, but they are related with it. So, it is not the if we take a silk fabric, it may not be the scroopy always, it may not be scroopy. So, that scroopy and silk like feeling. So, if we touch the fabric we tell that this is a silk fabric, we can make it. So, if we wear some silk cloth we can tell that it is a silk fabric. So, that type of feeling is called, it is a scroopy feeling. Shinai akasha, it is a soft, flexible and smooth feeling. So, it is not the only characteristic, we can say it is a surface related characteristics, it is a bending related characteristics, shear related characteristics. Okay. So, that type of feeling it is a Shinai akasha. It is influenced by bending, shear, compressional characteristics. Okay. Like if we have say higher shear, if we change the shear, it is a totally characteristics will change. Shari, it is very commonly used. Crispness, crispness in a fabric, a feeling coming from a crisp and ridged fabric surface. It is not smooth surface. If we actually move our finger, it should be some crispiness, some crispy sound should come, that we can tell it is crispiness. It is observed in densely woven fabric made from hard twisted yarn. We can just so if we develop a fabric with a soft yarn, very low twisted yarn, low twisted open structured yarn, that type of feeling it will not give our scroopy feeling. Now, if we keep on increasing the yarn density with a soft yarn, this will give some soft feeling, that will not get that type of scroopy feeling, some ridged structure, okay, the fabric surface that we will not get. But if we twist, if we make yarn with a say hard twisted yarn like crepe fabric, we know Georgette type of fabric, different high twisted fabric if we use, and if we touch we will feel some crispy touch. It is talking about that type of feeling, and it gives a cool touch feeling. It gives us some particular standard feelings like voile. It gives some special feeling which is shari, some special crispiness. So, there are two commercially successful instrument setups are available. These are for measuring the low stress mechanical characteristics and surface characteristics of fabric. These are Kawabata evaluation system as we have mentioned, and fabric assurance by simple test, fast measurement. So, we will discuss details about the Kawabata systems one by one, and then we will discuss fabric assurance by simple test method, fast techniques. So, this subjective assessment of fabrics like smoothness, firmness, fullness, crispness, hardness, they are directly related with the objective assessment of fabric. So, if we can measure the low stress mechanical characteristics objectively like tensile and shear, bending, compression, surface roughness, surface friction, all these characteristics, objective characteristics are directly correlated with the subjective assessment, that is subjective response of the wearer, like a tactile. These are the tactile responses, that whether the fabric is smooth or rough, they are related with this criteria. Firm, fullness, they are related with this criteria, but the importance of this criteria may be different little bit. Okay. Crispness are related with all these criteria, and the Kawabata and his team, they have developed equation, okay, statistical equation to measure, to correlate these objective parameters with this subjective. So, KESF, they have actually it is 4 modules of measuring the low stress mechanical characteristics. So, Kawabata evaluation system for fabric 1, which actually takes care of the tensile low stress measurement of tensile and shear characteristics. KESF 2, it measures the bending related characteristics, fabric bending related characteristics. KESF 3, it measures the compression related characteristics, the compressibility of fabric, recovery related characteristics, it is measured by KESF 3 technique. And KESF 4 for measurement of surface friction and roughness characteristics. So, this 4 techniques, and it gives all these 4 techniques, they give wide range of large number of parameters, and if we correlate all these parameters with the subjective assessment or this tactile responses, we can get some standard equations for a particular fabric. So, fabric specimen in KESF 1 system, the fabric specimen is actually clamped by 2 jaws. There are 2 jaws, and in KESF 1 we measure 2 techniques, 2 parameters. One is tensile related characteristics and other is the fabric shear related characteristics. So, here the fabric sample is clamped between 2 jaws. So, one jaw is actually it is connected with it is placed on a rotating drum, and another jaw is a transversely sliding jaw, it is a slider. So, one jaw is attached with the drum for tensile force application. So, as the drum rotates, it applies the tensile load, okay, and this drum rotates clockwise and anti-clockwise, and constant tension of 10 gram force per centimeter is applied by actually attaching weight on a drum. So, that constant tension, initial tension is applied, that is 10 gram force per centimeter. Okay. So, depending on the width of the fabric sample, the tension we can change to keep this. This is the low at a lower level of tension. So, to keep the fabric straight condition. So, as I have mentioned, the other jaw is attached with a slide. That slide moves laterally to impart the shear force. Okay. The picture gives the working principle of this instrument. Here, this is the fabric sample, fabric specimen, which is actually there are 2 jaws. This is one jaw which is attached with the rotating drum. Okay. This drum, when it rotates clockwise, it extends this gives extension to the fabric sample and gives the tensile load, and during recovery it gives the recovery. Now, the difference here in Kawabata system and with other tensile or other measurement technique is that here it's it works at low stress mechanical characteristics, at low stress level, and it gives the totality, curve in totality means it gives the extension and recovery. It actually records the value of force and displacement during extension and also during recovery. So, it is true for shear, true for its bending, it is true for the compression also. Okay. Now, here as it is rotating clockwise, it gives the extension, and during its anti-clockwise movement of the drum, the its reverse, its a recovery curve is achieved. Okay. Similarly, the shear is achieved by this slider. This is the slide for the shear force application. This slider moves laterally like this. Okay. When it moves this direction, there is a shear, and during return it comes back. Okay. So, during the lateral movement it gives the shearing. Now, the rotation of the curve, rotation of the drums, it's actually it's connected with some gear arrangement, and this it is connected through the tensile force detector. It is a torque sensor. Through this torque sensor, it gives the amount of force to rotate the drum, which is indirectly which gives the force to extend the fabric. So, this tensile force is detected by this sensor here, and what about the tensile extension? This extension here is detected by the rotation, amount of rotation of this drum, and that is sensed by the tensile strain detector. This actually sense the it is a angular rotation. Okay. So, this two sensor gives the tensile force and stress and strain. The senses and the signals from these two sensors gives the tensile curve. Similarly, this slider movement gives the shear, it helps in shearing the fabric, and this shear force detector means the amount of force required to rotate to slide, amount of force required to slide this slider is sensed by the shear force detector, and the amount of sliding is detected by the shear strain. That is, this angle of rotation is directly proportional to the amount of slide. So, the sensor this is this strain sensor, and this is the shear force sensor, it gives the shear stress strain curve. Okay. So, from this, so shear, the tensile force is measured by torque sensor, tensile strain is measured by the angle of rotation of the drum, shear force is measured by the transducer force required to slide, and shear strain is the displacement of the slider. So, displacement of slide is measured by the angular rotation of this slider. This is the slide angular rotation of this detector. So, from there we can get the shear strain. Okay. Now, let us see the animation. Now, first we will play for the tensile characteristics. So, this is the drum. So, for tensile characteristics when we measure, so in this instrument it works only one at a time. We cannot work both normally, we cannot work. So, this will actually, this is when tensile characteristics we will measure, this drum will be activated, drum will rotate, but slider will be stopped. So, this let us see. Now, the drum has started rotating clockwise. Now, tensile force is detected, okay, by the tensile force detector, and it is now it is coming back. Drum is rotating, started rotating anti-clockwise direction, and it is coming back, and at this point it has come back its original position. Now, the tensile total cycle is completed. Now, we can see here the important fact is that in this technique, as we have mentioned, that it takes care of the loading and unloading characteristics, total characteristics. Okay. So, from this curve, tensile and loading and unloading, we get different parameters. So, all these parameters from loading and unloading we get different parameters, and from shear we get different parameters. So, loading we from loading curve we can measure the tensile energy, area under the curve, linearity of the curve and resilience. Similarly, for shearing we get set of characteristics. So, this characteristics and all the parameters. So, there are different test parameters are there, there are different settings are there. This we will discuss in next class, and we will continue with this Kawabata evaluation system measurement. So, thank you for this day.